Hi, uh, my name is Siddharth, and I'm with my teammate coder Krishna Chaitanya. So this video is for the data center project that we've built, and our topic for our project is plagiarism detection using SimHash algorithm. So, uh, this software could potentially be used in academia, where professors could uh, check if students are plagiarizing their assignments. So, it's a really useful software, and we have sort of used this particular algorithm called SimHash to calculate, to manage the plagiarism detection in our case. Uh,
So, uh, SimHash is a technique for quickly estimating how similar two sets are. The algorithm is used by the Google crawler to find near duplicate pages. It was created by famous professor Moses Charikar. We try to replicate that idea and build a scalable solution. The SimHash algorithm comprises of the core business logic of our application, which is supported by data center components that were taught in the class as part of data center scale computing course. For the whole document, first n-grams are generated, and for each n-grams a hash is calculated and it's stored in the database. Whenever there is a new incoming file, the whole file is hashed, and those hashes are checked against the hashes in the database for similarity, and that's how we detect the plagiarism. So now we will discuss about the backend architecture.
yeah, we'll quickly go over the architecture diagram that we have. So the user is presented with a front end that where he could upload his document to check if he has plagiarized anything from the internet. Or so this uh, whatever content he uploads is basically matched with the corpus of data that's in our database initially. So he is presented with a endpoint to upload a document, and finally he expects a plagiarism report back. And so the front end is served by a React application from a Node.js server. And then this Node.js server talks to a backend Flask server that we use internally to uh, for all our Redis and RabbitMQ endpoints. So this is just a REST wrapper. So the backend Flask server is a REST wrapper for all our RabbitMQ and Redis instances. So and for since this is a compute intensive operation, like calculating the hash and then sending the report back to the user, we basically implement long polling on our Node.js side. So the user, it's an async operation. So the user uploads his document and is presented with a UUID, and the front end basically uses that UUID to query another Node.js endpoint at regular intervals.
So there is a backend API server that acts as the endpoint for the front end. The Flask API server, this backend Flask server has three endpoints. The first endpoint is to send the files which have to be hashed and saved in the database. These are called as the base documents. The second endpoint is to receive the files which have to be checked for plagiarism against the base documents. The third endpoint is to receive the polling output whether the document checking has been completed or not. The backend API server sends the backend API server sends the incoming files to the RabbitMQ instance, uh, which in turn sends the file to the workers in round robin fashion. The workers hash the incoming file and then check with the hashes already present in the Redis database to see if there is a match. We say that there is a match if distance between the hashes is less than a threshold. All such instances are then recorded, and final plagiarism result generated is again sent to the Redis database. So the front end now keeps polling this keeps polling the API server, and the API server keeps polling the Redis whether the computation has completed or not. And if the computation is completed, then the API server sends the plagiarism report back to the front end. Um, so the hashes are saved in both MongoDB and Redis, so that even if Redis goes down, it can get all the hash information from Mongo. So for testing, we did manual testing, and in the initial phase, all the tests are available in the code. We basically checked if everything is getting stored in the right format or not. And the main challenge uh, was that we used Redis JSON in place of Redis, as it supports saving the whole JSON document, but its library support wasn't that good, and we had to manually write our own wrapper to get around that. At each step in the code, to record important milestones, we sent logs to the RabbitMQ server for debugging purposes. During the development, we also used PyDB frequently to debug our problems. Each submodule of the project has been made into a pip application which can be directly be installed via Git, and they are subsequently used in both the API server and the worker code.
So for the Node.js side, we have monitoring set up through Sentry. So Sentry is an error tracking platform that mostly tracks app-based logs. We were actually on the free plan of Sentry, so it had like rate limiting and those sort of features. So we couldn't actually uh, send all our logs to Sentry. We are right now we are only sending the app logs to Sentry. So this is how our Sentry project looks. So basically, it has it has an stack trace of all errors or whatever is coming through. So this is where our front end is right now, this IP, and this is one of the endpoints which we use for polling, and this is the UUID that's generated initially. So Sentry, so this is where my Node.js instance is running. This is the host name on Google Cloud, and this is one particular error that we faced when debugging our code, and Sentry has a unified way to show the stack trace, and it becomes really useful during debugging. We'll actually go back to our architecture diagram and explain our DevOps pipeline.
So the whole DevOps pipeline, we used a Google Cloud Build to uh, whenever there is a GitHub push, the Google Cloud Build will immediately trigger the pipeline, and then uh, so uh, which would generate the images and then push to the Google Cloud Container Registry. Then we used kubectl to get the image and make pods or deployments. Every GitHub push trigger and cloud build and the status of the build is sent as a message to our Slack group. This was implemented using the PubSub.
So a typical Slack message for a success build would look like this. This is our channel that we have that we use to communicate for the project. Uh, Now we'll show a quick demo of our working system. So this is a very minimalistic front end that we have. We have a drop down area where people can drop their files that they want to check if they have plagiarized any content, and there's a small submit button that they submit once they upload the files, and finally they're presented with a plagiarism report here. Right now, because we haven't uploaded any files, you don't see anything, but let's go ahead and upload a file. So this file was built taking few texts from the corpus that we had. So it should return a few results. There's a submit button, the file has been uploaded, and like the spinner starts loading. So this is where the polling is actually taking place. We can go ahead to the dev tools, So this is the UUID. Right now, the operation is incomplete, so the data doesn't have any properties. So the polling right now happens every 5 seconds, but it's up to a user's preference, like how much he would like to set it to. So after, yeah, so right now we have data, so we should be able to see the report. Yeah, so this is our plagiarism report, and uh, if we closely observe, so this is the input sentence that is present in the user's document, and this is the reference doc has the document that is there in our database. So if we closely go through this document,
So in the plagiarism result one, so so if the artificial intelligence is applied to surgery navigation, a large number of patient data and knowledge and experience provided by experts can be collected. In the reference doc, something very similar is present. The intelligence is applied to surgery navigation. The intelligence is applied to surgery navigation. So there is means very much similarity here, and here a large number of continuous development of medical imaging technology has of patient data, and a large number of patient data and knowledge and experience provided by experts can be collected. So these are like at least in some part are similar, and here there's also one more thing, like experts can be collected, and here also there is like experts can be collected, so that is why our software has flagged it for plagiarism.
uh, right now we'd like to show the we have a logs a pod that basically streams all logs from RabbitMQ, and this is a strat driver which basically has all the logs.
So all the newer logs means these are the newest logs. So for example, like the last uuid.txt which was sent, you can
So this was the UUID that was generated, and it can be seen that the worker, when it started processing, so it downloads this file. So this was the UUID again, and then it sends the result to Redis.
Redis, yeah.
Uh, right now, we'd also like to show our DevOps pipeline that we have.
Yeah.
So my friend would like commit a small change to one of the files, and we can see the commit on our Git repository that we've been maintaining for the project. So the last commit was 2 hours ago. So we have just pushed a commit right now. This indicates that our build is running. So this basically triggers a cloud build job to run our to build our code and push it to Google Container Registry.
So here you can see that this committee is still running. The pipeline is still working, and whenever like everything would be run, so there would be a green symbol at the top showing that means all the pipelines have been built successfully and all the images have been deployed successfully. So right now the build is successful, so we can check our Slack whether we have got the message or not. So yeah, so just at this time
We received a new
we
message.
received a new message that uh, the status is a success, and it has went ahead and also pushed the
Deployed it.
latest, yeah, image to the Kubernetes cluster.
Uh, so we really enjoyed and learned a lot like during this project. We just wanted to highlight a few potential bottlenecks that our system could face. Uh, because we are implementing long polling and we haven't gone like totally async by emailing the uh, plagiarism results to the user. One potential bottleneck would be if there would be multiple requests. So one of the endpoints will be frequently polled. Let's say like someone we receive 100 requests, so at each 5-second interval there would be around 5 into 100 times the request. So that's one potential bottleneck for our Node.js side, which can be overcome by placing an application load balancer, but that would also incur like huge costs. We'd also like to take this opportunity to thank Professor Dirk Grunwald and the TAs who've been very helpful and supportive throughout the course. And we particularly learned a lot through the assignments and the course project.
Thank you.